Hey, 7th graders, you should have your Bikini Bottom Genetics Punnett square practice out. Going to give you a few helpful hints as you are going through this. Keep in mind the purpose of this is for you to understand Punnett squares, which are going to explain the possibilities of how certain genotypes can go ahead and interact during sexual reproduction. So before we can do that, we first need to go ahead and review some different terms. First one here being heterozygous, which means different. Homozygous, which means the same. So each one of these different sets of letters is representing a genotype. That's the genetic makeup of the alleles for a certain trait. So right here where you got capital T, that is going to be a homozygous because they're the same. So as the instructions indicate, we'll go ahead and put an HO by that one. Go ahead, find, let's look at this one right here, little b, little b. They're both the same, obviously, both lowercase, so that would also be a homozygous. One of the terms that you got from your reading was also purebred. If it's homozygous, also means it's purebred. So now when we go ahead and look at something like big T, little t, you might be saying, well, they're both the same. Well, yeah, it's the same letter because it's a trait for a certain characteristic, but the different forms or the different alleles, you've got a dominant and a recessive one. So that's going to be a heterozygous genotype. So we would go ahead and put a HE for heterozygous there. You also have another heterozygous one right here. And then you can go ahead and figure out the rest of them. Keep in mind, heterozygous means and hybrid are the same. Homozygous and purebred mean the same thing as well. So right here when you find which of the genotypes would be purebred, you would list all the ones that you have homozygous for. Right here which ones would be hybrid, you'd put all the ones that are heterozygous. So now moving down to the second part, I'll do this first one together with you. Okay, it says determine the phenotype for each genotype using the information provided about SpongeBob. So if yellow body color is dominant to blue, that means that yellow is dominant, blue is recessive. So from your reading, remember anytime you've got a capital letter, that's showing you that you have the dominant trait. So big Y, that's going to be yellow. So then in order to be blue, you have to have both of the recessive traits. So little y right there, that is blue. Then when you have one of each, you've got one dominant, you've got one recessive, but the dominant's going to overpower or block the recessive. So instead of being blue, you're going to be yellow. Moving down to number 3. For each phenotype, give the genotypes that are possible for Patrick. So remember, phenotype is what it looks like. Genotype, that's going to be the letters or the genetic composition. So in this case, having a tall head, that's capital letter, so that's going to be dominant. So anytime you're going to see a capital T, you know it's dominant. If you've got a little t, that's going to be short eyes. Or I should say a short head, my mistake. So for these ones where you have a dominant trait, there's going to be 2 potential genotypes. If you have both alleles are dominant, you're going to have big T, that's going to be a tall head. Big T, little t is also going to be a tall head. Then a short head, since that's recessive, the only time you're going to see a short head is if you have little t, little t. So now that we've reviewed heterozygous, homozygous, taking a phenotype, making a genotype, taking a phenotype, making a genotype, it's time to go ahead and finally do a Punnett square. So with that in mind, we're going to go ahead and start right here. Let me adjust my camera so I can get everything in the screen. Let's look at number 4. So it says SpongeBob SquarePants recently met Sponge Susie Roundpants at a dance. SpongeBob is heterozygous for his square shape, but Susie is round. Create a Punnett square to show the possibilities that would result if SpongeBob and Sponge Susie had children. So hint, it says read question 2. So when we go back up to question 2, it says square shape is dominant to round. So we know that anytime you have a big S, that's going to be square. Little s's are going to be round. So if we take that information, we know that SpongeBob is heterozygous for being square. He's going to be a big S, little s. And then Susie, she's round. So the only possibility there is little s, little s. So when we put this in a Punnett square, one of the parents' alleles go up top, the other parents' alleles go on the side. So for SpongeBob being heterozygous, we're going to put a big S and a little s. Now you can see I'm being rather obnoxious with the size of my s's. That's because big S and a little s are hard to differentiate between. So make sure that you can clearly tell the difference. And then Sponge Susie, she's round, so she's a little s, little s. So now the way that these Punnett squares work is you drop down, go across, go across. So I'm going to drop my big S down, then I'm going to drop it down into this box too. Then I'm going to take this little s, drop it down. So remember, during sexual reproduction, you have genetic information from mom and dad that come together to determine the baby's genotypes. Okay, so this is essentially the alleles that SpongeBob was able to donate. Now we're going to go ahead and bring Sponge Susie's over. So we're going to bring her little s over. We're going to bring her little s over. Then down here we're going to bring her little s over. Going to bring her little s over. So that's our completed Punnett square. So basically what this is saying is if there was 4 children, these are the potential possibilities that you would have. So every time they would reproduce, these would be the potential outcomes that you'd see. So letter A lists the possible genotypes. Remember, that's the letter combinations. And phenotypes, that's what they look like. So possible genotype that we would have, we've got big S, little s. That'd be a square child. Then we would also have little s, little s. That would be a round child. So then when we go ahead and look at B, what are the chances of a child with a square shape? Remember, square is dominant, so anytime you see a capital S, that's going to be square. So big S, little s, that's square. Big S, little s, that's square. Little, little, round, little, round. So 2 out of 4, or 50%, will be square. And 2 out of 4, or 50%, will be round. Alright, I'm going to do one last one with you before it is your responsibility to finish the rest of it. So a little bit more SpongeBob love here. So we've got Patrick met Patty at the dance. Both of them are heterozygous for their pink body color, which is dominant over yellow. So capital letters going to be pink. Create a Punnett square to show the possibilities that would result if Patrick and Patty had children. So it says hint, look at 3. So 3, we're using the letter P. Big P is pink, little p is yellow. So looking back at our clues here, we know that both of the parents are heterozygous. So that means they have one of each allele, big P, little p. So when we set our Punnett square up, we've got a big P, little p, big P, and a little p. So we got Patrick and Patty. Once again, one parent's genotype, the other parent's genotype. So do our Punnett square, we're going to drop that big P down into both of those boxes. Here we're going to drop the little p down. Here we're going to bring the big P across, big P across, little p across, little p across. So we have 3 different genotypes here. We've got a big P, we got a big P, and a little p, And we have a little p and a little p. So if we remember that pink is dominant, we got a capital P, so that's pink. We got a capital P, so that's pink. We have two lowercase p's, so we know that that is going to be yellow. So going over the potential offsprings, we got big P, pink, big P, little p, pink, big P, pink, little p, yellow. So we've got 3 out of 4 that are going to be pink. That's a 75% chance. And then we've got 1 out of 4, or a 25% chance of them being yellow. So when you go through and complete the last 3 Punnett squares and also finish the other questions on the front, make sure that you refer to what we've done if you have any questions, and you will be having a quiz on this in the upcoming days. So make sure you do get it completed.